Okay, so thank you again for being here, attending this webinar. It's 2:05, so we are going to start right now. Okay, let me just show it here. So good afternoon again, and again, thank you for attending this webinar. I am Álvaro Correal. I'm a civil engineer with 18 years of experience in construction and consultancy. And I have been working for Forza for the last 9 years. I have had the opportunity to be in many projects, assessing and giving accompaniment to many constructors in more than 20 countries, probably. And for the last 3 years, I've been focused at African and Middle East countries. Please, if you have questions at any moment, go to the questions and answers link below, and just write your question there. At the end, we will have some space to answer all the questions that you may have. Okay, thank you very much. Okay, so the topic that we are going to talk about today is the importance of the industrialization of construction in times of crisis. Let's go to the matter right now. Okay, so how to succeed in a construction project. You know that to succeed in a project, you need to achieve a full scope in time and with a final client satisfaction. That's not easy to achieve, and projects, as you may know, like 95% of them doesn't achieve these three topics at the same time. But with industrialized systems, it's easier to achieve that because it's easier to plan and easier to control. But we are going to talk more about that in this webinar. But also today, it's very important for us to consider the health of the workers after all this pandemic that we are living through. So to keep our project at execution, we need to comply with protocols, and we need to create a culture in our works, in our projects, for the workers about self-care awareness and about control. We were used to be controlling all the technical aspects of the work, but today we also need to consider the health aspects involved with working with people. Construction stages. So at the beginning, there is when you are thinking about building a project, you go first to a planning stage. In this planning stage, you are going to calculate your budget, the required equipment that you are going to use there, the labor, and the materials. But today, it's also required to include biosafety equipment and measures to guarantee that our workers, our staff, is going to be healthy. So for this reason, we need to consider additional time for workers for the process of access and exit the work site. We also need to consider the hours for material delivery, the amount of personnel on site. This is very important because probably local regulations is going to tell you that how many people can be in one place at a time. So you have to consider that. We are also going to be exposed by inspections by authorities. So this is also time that you are not going to be in the building, but attending these visits. And at least weekly, you need to have a talk with your workers about the importance of the correct use of the personal protection equipment that they have to use every day and every time, and about self-care. So with all these considerations, we have to adapt to these requirements and adjust labor amount, the schedule, and our budgets. I'm just trying to, let me do something here. Oh, what happened? Oops. Okay, so we were at the planning stage. Right now, after that, you go to choosing the optimal solution for the project construction. In this case, we are talking about industrialized construction, and then you proceed to the execution of it. Execution can be this slide, even if this is not an industrialized project, but a conventional system. But it's here on purpose because we want to show you that control on the execution when you are working with industrialized construction is easily done, easier than when you are working with traditional systems. So at the end, you will have finished your project in less time, saving resources, and the more important is that you save resources, but without affecting the budget, employment, and the quality of the final product. At the execution, so it's very important for us right now and always, but we have to include new checkups that you must do. But as I was saying, so you need to have at least one leader who masters, can be this guy, who masters his job to lead every crew. So you will have a crew for the formworks, you will have a crew for the MEPs, you will have a crew for the steel installation, everything. And this guy must lead the quality, of course, the technical aspects of the work, but also the instructions for these guys about self-care and about caring for the other one, to keep control over the group about their activities, and to give instructions on daily labor. This guy, we need to have a new kind of professional on site, because we used to have someone here like a foreman or a junior civil engineer, and he was checking all the technical aspects of the works, but we also need this guy, or to have another one in charge of not only monitoring the activities and predecessor activities and doing checkup lists and documentation and everything, but we also need this guy to be working on safety and health inspection. So this guy must guarantee that all the other guys are using their personal protection equipment, that they are complying with the norms, like washing hands every 2 or 3 hours, depending on your country, and to guarantee that these guys are not talking in the hallways with each other, that they are not sharing food, shaking hands, or having fun or whatever. And also avoid these guys from crossing in mobility zones. Okay, so this guy is going to do all that, and of course he's going to do this continuous improvement about cost savings, resources. I mean labor, materials, time, and waste reduction. Efficiency, of course, you have to improve every time you can. Quality, and to diminish the risks involved with construction. Okay. Efficiency, we define it here as achieving the same objective with less resources. So the processes must be well defined with actors of every activity. They should have responsibilities defined according to the expertise of these guys, of these actors, and the time that must be adjusted by these new protocols for the pandemic, and the cost, which is related to increase the productivity and the efficiency. Okay, now we are going to have a look at this comparison of schedules. We have here on the top an industrialized system schedule, and here on the bottom we have a conventional system. This orange color is the foundation. As you can see, it's taking the same weeks for both systems because it's basically the same activity. This blue one is the superstructure, and this in industrialized construction it's taking only like 2 months and a week, and here in the conventional system is taking like 4 months, so double the time. We will see that later. The green color is the inner walls activities. So it's probably you have here in conventional system, you have to build inner walls with bricks or gypsum or any activities related to the inner walls. In the industrialized system, as you know, you pour the inner walls and the outer walls and the slabs at the same event. So probably all this together, the blue and the green, is all the structure. And if you join this together also in the conventional system, so you have like 2 or 3 times for the same activity. And this pink color is the finishing stage, which, as you are already working with our systems, you know that with our system you achieve a very flat surface, so it takes less time to do the same finishing when compared to conventional systems. So as you can see here, it's also like 2 or 3 times for this activity. At the end, you will have a shorter execution time. In industrialized system, it was like probably 8 months for this project. And in conventional system, it took like 1 year and some months, like 1.5 years probably. So a shorter execution time means less labor, less administrative costs. When I'm talking about administrative costs, I'm talking about supervision staff, security guys, technical support, storage, and a shorter execution time also means today, very important, less risk of contagion. Okay. So the ideal today is to have this kind of systems, because your execution time is shorter, and I already talked about the advantages of execution in a shorter time. You have less activities to control, so it's easier to control, easy to plan, and easy to finalize your project with something very similar between what you planned and what you finished. Okay, now we are going to talk about labor estimation. For labor estimation, we need to consider some activities like the formwork works, the slab works, or works at the slab at noon, and concrete pour. But you also need to consider the distance that these guys are going to be moving the formwork. You also need to consider the self-care and where these guys are going to probably meet each other. So we need to create roads, additional roads, to avoid this crossing, to avoid the workers to be in contact. So the normal performance for shorter hands, I mean the guys working with the formworks, with a novice guy, with a built-up area, talking about built-up area, it is 0.75 square meters per hour per man. And normal guys, which I mean are guys that maybe have had the experience with the mold for 3 weeks, 4 weeks, they can be working and achieving a performance of 1 square meter per hour. This is built-up area. And the experts, these guys are guys that have been working in the market for years. They can do up to 1.2, 1.5. It depends on the guy. I'm talking about normal projects to make a comparison with normal project and another normal project. I'm not talking about hotels and other kind of special structures that maybe requires very tall free heights and many architectural details. Okay, if in this table you will also have the performance, but measured on aluminum surface, not built up area, but aluminum surface. Okay, this is basically the same, but multiplied by 5. Okay, so a normal day, you start at 7 a.m. The former works, it's striking. Then in the middle of the morning, you will be moving the formworks from one place to the new location, and then assembling these formworks on the new apartment. So this activity normally it's about 5 hours. We also have measured this, which is important, that a normal shutter hand can carry between 20 and 25 square meters per hour. So that's 600 or 700 kilograms per day. This is normal for these guys not to get sick. Again, we are talking about the health of the workers, so you need to consider this. Okay, so at noon, you need to consider a couple of hours also to do the works at slabs, and after that, then you pour the concrete. So this is important, the concrete pour. You need to, today it's very important to finish early. This is to avoid the workers to go back at home at crowded hours. Okay. Here in slab works, let me clarify that I'm talking about the steel and mesh installation, rebars, if you have in your structural design, piping installation, and review and approval of the work. Sorry, let me see something here. It's okay. Thank you. And yeah, that's all. Let's go to the next slide, please. Okay, in these daily activities, I'm going to talk a bit further about all these activities that we are mentioning here. Okay, so striking, the normal performance for a guy, but let me talk first about this apartment. This apartment, it's probably 55 square meters, and we have here 9 shutter hands in total. Everyone, each of them, they have a well-defined area. We have 1, 2, 3 guys working at the outer walls or facades. These guys at facades are away from others, avoiding being close to the workers inside here. So, and we have 6 guys working on the inner walls. These 6 guys, if you divide this 55 square meters apartment by 5, means that the media is that each guy is working like 9 square meters. So that's a good area, thinking about how far they have to be from each other to guarantee these protocols complying. But it's also very important that because these guys are going to be moving the formworks when transporting, to check and to guarantee that they don't stop here in this critical road and they don't cross too much in this part. Okay. So every activity that we do from 7 a.m. to noon is, the first one is striking. The normal performance is 3 minutes per square meter. This is aluminum surface. So normally it's each of these workers is going to be striking 25 square meters per day. So it gives us 75 minutes for this activity. Let's talk about 90. Okay, let's go a bit up. Let's go to this one, to the assembly. This assembly is also the same performance, 3 minutes per square meter of aluminum surface, the same amount that they move per day in this exercise, which is the real one, and it gives us also 75 minutes. Let's talk about half an hour again. Okay, so these two activities is giving us 2 hours, striking and 3 hours, sorry, striking and assembly. So we have 2 hours left for transportation. Okay, so it's very important. It becomes a crucial activity because we are talking about these guys moving 25 square meters per day, and that give us, if we divide by like 1.14 square meters per like a media of the formwork that they are moving, it gives us 22 trips. When a trip is when this guy takes this formwork from here and move it from the same place to the same place on the next apartment. Okay, so we need to consider the two critical points. The first one is the time that to go from one point, let's say this point, the farthest one, to the same point in the next location. So this is the farthest point, and this is going to be the longest trip that this guy is going to do. So we need to consider that one. And we also need to consider the time that these guys are going to be stopped here because there is another guy passing through, or the time that they are going not to be stopped but slowed because of the same reason. Okay, so very important. Now, after that, we already talked about the morning. After that, when you have all the formworks installed, you proceed to the activities over the slab. Okay, so normally these activities are rebar and steel mesh installation. The normal performance is from 10 to 15 square meters per hour per man. It depends on many things. It depends on the slab area. The biggest, of course, you're going to need more workers. Depends on the steel amount, which is defined by the design, the structural design, and the work site equipment. Why I'm mentioning that? Because it's not the same to be cutting the steel there than having it all pre-cutted. It's when you have a crane also to move and put this steel mesh or all the rebars there, it's easier and faster than when you do it by hand or when you have to do it using the stairs. So it's very important to consider that. MEPs, no, we don't have many mechanicals, but we have electricians and we have piping. This activity also depends on how many plumbing points you have, the type of pipe that you are using, and please consider that this activity must be made at the same time or simultaneously, sorry for my English, with the steel installation. Okay. And this review and approval, you have some guys in the work, you have the contractors, and you have also supervisors and probably some consultant that needs to go and review that everything is placed as it's supposed to be and approves. But it's also important that these activities are done at the same time that they are doing some activities, not to wait until everything is finished. So you have to stop just for these guys to give a concept. So very important to think in industrialized not only as buying and having a set, an aluminum formwork set there, but to have all the activities linked together and to remember always that every activity is linked together and must be considered to be optimized to get the most efficiency, the most efficient processes every time. In this table, we have some, having told everything that must be considered there, we have some like a media of the number of persons that you need in each group. Let's say you have this 61 square meters apartment, then you need 3 guys to do the plumbing, 3 guys for the electrical, so you will have 6 guys working on MEPs, and guys installing steel, you have 6 guys at least, and that's a normal performance. It depends on the country and the expertise on of these guys, and the way that you also are incentivizing these people to do their jobs in a very fast way. Something important here to mention is that many of our clients, constructors, have already started construction after the pandemic, and it's curious, but they are working with the same staff that they were working before. Even if they have to consider that these guys have to arrive 15 minutes early because they have to do these protocols for entrance and everything, but they are using the same staff, which is very good for the system. Concrete. So in this image, we see 1, 2, 3, 4, 5 guys pouring the concrete. It can also be optimized, but I want to mention here that at least these guys are well separated, more than 2 meters away. So thinking about the health and the new requirements, they are complying with all these local regulations. Oh, a concrete pour. So for this, we are talking about performances. We need to consider the volume. We need to consider this pouring equipment, how many equipments you have and the capacity of them, and to guarantee a continuous supply. This is very important because you can be there, and if you are working, let's say, with ready mix concrete, and you have to wait for the next car to arrive with the concrete half an hour, 15 minutes, and you have to pour 3 cars, so you're not going to be as efficient as you can probably be if you are preparing concrete on site, or if you manage to deal with these guys to guarantee that they have the cars one after another to have a continuous supply. Okay, I was seeing that there is already one question there, and let me remember you that every question that you have, please go below to the questions and answers button and write it there, and at the end we will have some time to answer. Okay, thank you. The slab surface finishing. For this, it depends on the built-up area and the method that you are using to finish this slab, because you can be working with helicopters or you can be doing it by hand, so it's not the same. But a media that we have found for the constructors that are using this system is between 25 and 30 square meters per hour. So for this example, we said it was 61 square meters, so it will take like 2 hours to finish this slab. And remember that is very important to have a very well leveled slab, so we can optimize the installation of the formworks upon it. Very important. Now in this table we have some time that we have measured, and if you are pouring 8 cubic meters of concrete with pump, it will take 20 minutes to pour it. That's 1 car, and with a crane it takes 60 minutes, so it's 3 times. I know it's not usual in the Caribbean islands or in Africa or Middle East to be pouring with cranes, but in Latin American countries they are still doing that. So this is something that they need to consider and to change, probably to pumping the concrete, because as we said, it's very important to finish as soon as possible so these guys go home early. Something that I didn't mention before is that most of the time when you are talking about how many labors you need, it's like 30% for the facades and 70% for the inner walls. Okay, so let's start with an example. This, we were talking about 61 square meters with a cycle time of 6 hours here. When this cycle time is the time that it takes for striking, transportation, and assembly of the formworks, okay? And the performance, we are going to use 1 square meter per hour per man, which was the, if you remember, the normal performance of a man, okay? So the formula, this is the apartment, 61 square meters. It's just basically, you divide 61, let's see it here, 61 or 60 square meters by 6 hours, and then you divide it by 1 square meter, so you need 10 man. And then you make the distribution. Let's see if it works. You have one in this space, 2 for this space, number guy, 3, number 3, number 4, 5, 6, 7, 8, and then you have 2 guys working at the facades. Oh, and this guy. So you have 3 guys working at the facades and 7 working inside. Yeah, it looks like a well distributed way for these guys to work. For the safety system, which is very important also today for a safe work at heights, it's imperative to have a safety system like the one Forza have designed, because this system allows the workers to walk and to work at facades with ease. And Forza has designed a complete system that complies with the most demanding norms and regulations, international, like the OSHAs in the US, the Brazilian codes. So this system guarantees that your workers, if installed correctly, of course, that your workers are going to be safe working at heights. Our recommendation, talking about how many sets or how many perimeters you need to have, our recommendation is to have 1 perimeter of the whole floor, as you can see here. The whole floor, not only the perimeter that you are working in, okay? And additional to that, have at least another one for the upper floor. So, because the more perimeters you have, the less workers you will have using the same paths. That means less risk of accidents and less risk of contagion again. It's also ideal that before installing the formworks, there is a crew, the crew that is installing the formworks. These guys must be like 2 or 3 apartments ahead in the installation, okay? So we need to consider that these guys are going to install the scaffolding, which are these triangle shaped things here, the platforms, which is the yellow planking that these guys use as a path to walk, and the guardrails, which are these blue pieces with these yellow bars. So the whole system must be installed to guarantee the safety for these guys. And the performance normally is that it depends on how many linear meters you have. So for this example, let's say you have here like 10 meters for this part. You have a balcony here, so 10 meters. You have probably here like 5 meters of this part, this and this wall, 6 meters, and for this part you have like probably 5 meters or something, because it's only here, not until here, but here. So that gives us like 21 linear meters. So you will need, for this example, you will need only 2 guys to be working on the scaffold. Very important. So that was the first example. We're going to see a couple more, but to talk about costs and other things. And some of the advantages of our systems that you may already know. The first one, you know that Forza systems are you get many benefits, and the first one is savings in finishing. All these 5 benefits that we are going to talk about are focused on efficiency, because if you get less costs, less resources, and a reduced execution time, and less waste and less risks, then you are most efficient. Okay, so savings in finishing, as you know, our walls, the surfaces, sorry, are very flat. You have corners, very well-defined ones. The windows and everything that can be optimized, and they are very precise. So at the end, all of this, it's going to represent money in finishings. Less money, less resources, less workers, less risk of contagion also. Second benefit that you will get is the reduction of administrative costs. If you remember, in the schedule comparison that we made, it was 8 months against 15. So that's 7 months, or even like half of the time of the project, when you are going to be saving money on all the fixed costs that you have, the water that you need to supply, the safety, the security guys that must be there, everything, the engineering, all the guys that must be there supervising, not only the guys on the execution. So if you compare at the end the savings, of one system against the other, you can be saving up to 40% the costs compared with traditional systems. Another benefit that you get with this system is less and more productive labor. If you see here in this image, there are 3 guys pouring the concrete. So this guy here, there must be some other guy, probably maybe this one, doing some like vibration, or maybe he's just moving and handling this pouring equipment. But what I want to say is that it's very efficient, and that you don't need many workers to use this. So again, less risk of contagion. Workers, as you are going to put the workers on an area, and they are going to be working on the same area every day, so they become specialized and they become experts with just some days after repeating and doing the same every day. So this system is very light, it's hand portable, and that allows the shorter hands to work orderly and with better performance, as I said before. Each worker can assemble a big area, and that reduces the required labor, and again, less risk of contagion, which is the message that we want to leave for you today. Another benefit is less waste, okay? Because as you know, when you are pouring monolithic walls and slabs, I mean, you are putting the inner walls, outer walls, and the slabs at the same time. So you achieve better finishes. You reduce additional activities, you reduce corrections. The concrete placing is precise, so it reduces concrete waste. And something that is not very often mentioned is the debris disposal. With this kind of system, You don't have to use wood and you don't have to use additional materials. So the bricks are only some small waste of concrete and probably the tie covers. It's not too much. So this benefits the, the environment and also your budget, because you don't need to have many trucks moving debris and waste every day, like I have seen in traditional systems and you've probably done before. And the fifth benefit that you get with this system is the concrete finish. You know that the ACI is asking or having outlining a requirement of 6 millimeters of tolerance for concrete to be exposed and 7 millimeters for concrete that is going to be painted. But Forza guarantees only 3 millimeters when you receive your formula. So if you install it in a proper way, if you have good practices every day at the assembly and you make the correct maintenance to the formworks, you can achieve that minimum deformations. So concrete finish, as this guy is looking at the concrete there and he's in love with it, is because it's very flat. Okay, so we're going to talk about cost comparison. This is, if you like the numbers, this is the fun part. Okay, so we are going to talk about a comparison, direct cost of the thick work, the cost per square meter of built up area, the savings that you will achieve for materials and labor for each activity, the total savings that you're going to obtain by building with aluminum systems, and the percentage of incidence of the investment in the formworks, or I mean the cost of the formworks in the total construction cost. Because you can probably think, okay, this is expensive, but it's an initial investment that you will recover and you will go to a break-even point, and you will see that it's achieved easily. So we have this houses analysis. Important to show you that with this system you can do whatever you want. So you can have these architectural details like these columns, not only the walls. You can build with the sloped or inclined slabs like you see in this project. A very simple one like this one with a different kind of roofing. Two stories houses. We are talking about houses in this example. We are going to do an analysis of an actual project. This project, we are going to compare a concrete house versus a house that was built with blocks, concrete blocks. The project was 500 houses in El Salvador. The built-up area was 100 square meters. They had only one force set. We are going to talk about US dollars, talking about the currency. Walls and slab thicknesses was 10 cms. The steel reinforcement was 15 kilograms per square meter. Free height 270, and concrete was ready mix. And the formwork area, it was 513 square meters. Something important here to tell you: if you want to calculate in a very fast way how many formworks you need for a project, if you divide this here by the area, built-up area, you will have like 5 point something. So if you multiply by 5, if you have, let's say, an apartment or a house 60 square meters with slabs, you multiply it by 5, and then you will have an accurate number of how many square meters you need for this project to be built. Okay, so in this exercise, we made all the numbers for these concrete masonry houses and for the Forza system. The difference here is that with the concrete masonry, you don't need to do an initial investment. So it's 0 here. with force system, you need to buy the system. So there is this 437,000 US dollars. The materials, you can see a slight saving here, 338, not very slight really. Labor, you're going to save some money also here. Materials for roof, another saving. So at the end, you have all the activities here, and at the end, you're going to have a total cost for this. Let me remember, 500 houses of 6 million something, and with Forza system, it was 5,200,000. So the total savings for building this project with Forza was more than 1 million US dollars. Cost per house, if you compare it, 12,000 against 10,000, and the cost per square meter, 127 against 104 for the Forza system. Okay, so the savings per house were 2,345 per house. This is per square meter, the concrete volume that you were using, just numbers to show you at the end that the savings for this project was 18% on the cost of the project. And something more important, you also have the Forza system. You already bought it. So you earned 18% on a Forza system. You used it only 500 times, but the lifespan, the expected, is 1,500 uses. So this system can be used to build another couple of projects the same size of this one. And you're going to be saving 437,000 US dollars. So this is very good. Construction cost, sorry, there are some words in Spanish, but I can just show you. Here, this blue is the Forza set that you had to buy at the beginning. This is the cost of the materials for the structure and the cost of the labor for the structure. And then here is where you have the more important savings, and it's everything else. Here you have the roofing. This red one is the general or direct costs of the project, which we already talked to a lot about that. Also the finishing, the thick works and everything. This is where you are saving 18%. This is in terms, the comparison in terms of the cost impact. So the materials, almost half of it, labor, materials, this is for houses again, and the general fixed costs or administrative costs, the most important ones there. This is the direct costs and the total savings, and see how they impact in absolute values. So the Forza set cost is here. You have also, let me see, general, this is the administrative cost, rendering materials. You see how important they are, the rendering labor, and this is the materials. This is the most important savings that you are going to get with the industrialized system. And the break-even point, it was achieved at the house number 163. This is where the investment that you made on the formwork was recovered. This is where you paid for your formwork, and then you start to earn money and to be more efficient than this green one, which is the concrete blocks construction. Okay, this is an apartment building analysis. Let me see the time. Yeah, we are okay. Anyway, we're going to talk this a little bit faster. This project was in Brazil, 200 apartments, built up area 69 square meters, one Forza set. Numbers are in US dollars. Wall thickness and slab thickness are 10 cm. Steel reinforcement was higher, 20 kilograms per square meter. Pre-height 270. Concrete, ready mix, and formworks area 354. Again, if you multiply like 70 by 5, it's 350. And you see here, very similar. Again, the comparison, and this was only 200 apartments, only 200. At the end, you have a total cost of 2 million and 1 million point 6 here. So you're going to be saving 500,000 US dollars, the cost per house. So the savings for this project was 23%. And again, you're also having the force system at your disposition, and you can use it. You used it only 200 times. And if you can use it 1,500 times, then you can use it for 4 or 5 projects more, if you compare it to this one. Construction cost, again, you can see a big difference here in the labor, a very big one. Another one important here is the administration. And this purple one is the finishing stage. So at the end, in this project, they were saving 23% of the cost. Impact, again, you can see let's see the next one, which shows you more. Masonry, this is the very big difference. The labor for masonry and structure, you're saving like 14% here. Materials, you're saving 6%. For rendering, in between materials and labor, you're saving like 8%, and general fixed costs 6%. At the end, you have 23% costs savings. Break-even point for these guys was even shorter, and in the use 89, they reached this point where they paid for their investment in the formwork system. It's very nice. So general recommendations. Why we are talking about this? Because it's, as I said before, it's not only to buy the system and to have it there, but you need to adjust all the activities, earthworks, urban planning, the networks, the licenses that you will get, procedures, everything. You need also to take your project design and adapt it in standardized dimensions, free heights, to think about them. How are the dimensions of the tiles, the windows that you get in your country, if they are standard or not, the doors, everything. So how you build the foundations, if you're talking about houses. So everything must be industrialized, all the activities. So you have this working like a production line. Last example on savings. This project is 10 buildings. Each building is 9 floors, 4 apartments per floor. So you have 36 apartments per building. And I said 10 buildings, so it's 360 apartments. Okay, so we have this number here. And the labor, we said that if you compare this, we are going to make a comparison. If you use the aluminum formworks and if you rent a steel formwork, which is the possibility that you may have in your market to rent a steel formwork, you know that the guys that are working with the aluminum are charging $1 less per square meter when compared to steel. So for this house, apartment, sorry, you have 60 square meters slab and you have 120 square meters walls. At the end, you have 180. So you are going to be saving 180 US dollars per apartment. And you have 360 apartments. So only in labor, you're going to be saving this amount, $64,800. For structure corrections, by experience, I can tell you, and experience by our clients, that additional activities for corrections, for this kind of corrections that you see in these pictures, for the corners and for all these like not too good finishing that you get with the steel, you can we can say that $100 is the amount that these guys are paying to do these corrections of these things. So the total amount that you are going to be saving is $100 per apartment. You multiply that by 360 apartments. That's $36,000. Concrete waste, when you are pouring with steel, you have to pour the walls and the slabs at different stages. So the waste of concrete is increased by far. It's like 4%. And 4%, if you are talking about a 20 cubic meters apartment, just in one apartment is, let's do this. Concrete cost, if you are paying $100 per cubic meter, and you multiply this by 4% waste, by 360 apartments, by the cost of the concrete, then you will be saving $28,000 for concrete waste. Slab joints, this detail, you know that with force of formworks you can achieve this. You can also leave it like this with a group that we include in our formworks and the group angles. But if you don't have that with the steel formwork, you are going to be paying $1.5 per linear meter. So at the end, it's like 45 for this example, $45 by 360 apartments. So that's $16,200 more that you are saving only for this concept. The crane, if you are using steel formworks, then you'll need a crane because they are very heavy. If this project is built in 18 months, then you will be saving $54,000. And steel forms renting. Normally, the rent of a square meter is 0.25 or 25 cents per day. And we said that we need 300 square meters of surface of the formwork by 30 days per month. And it was 18 months. So at the end, if you multiply all these numbers, you have $40,500 more savings. So at the end, in labor, finishing, concrete waste, the slab joints, the crane renting, steel forms renting, you will have savings of $240,000. With this money, you can go and buy an aluminum formwork system, which is by far better, and you can get better results. So this was all that we wanted to talk about the performance, and I also want to show you the products that we have developed and that is important for you to have in your projects. The first one is the sanitization cabin, which sprays this alcohol or whatever you need to put inside, and it has a sensor, and so the worker goes inside and comes the other side with a bath of this material, this alcohol. Portable sinks. Basically, you need to put this in some locations of your project to guarantee that these guys are washing hands every 2 or 3 hours. And the gel and soap dispenser. These are designed to be rough, to be able to be used in work in projects conditions, because you know we are not working with gentle ladies, so they're very rough and resistant. Okay, so thank you very much. This is my email there. Thank you for your attention. And right now I'm going to have a look at the questions that you have made. Okay, there is some question here. It says, Are there technical solutions that can be used to generate other circulation points to prevent assemblers from crowding at a point or high flow of people? Yes. Let me go back in the presentation. Yeah. Let's see this example here. So this is the hole, okay, and this is the circulation that can give us some problems, some issues with the guys crowding there. With our safety system, we can have this area joined together so the workers can go to the next apartment using this path, okay, and maybe they can go outside using somewhere here using the safety system, and they can go to the next apartment. And this is imperative, let's say, for the guys working at facades. These 3 guys in the example, they cannot go inside, they cannot be using this hall. So this is 3 less guys working outside if you have the safety system installed. Okay, I hope that this answers your question. Another question from Ricardo Rodriguez. What kind of system or accessory have designed to guarantee the accurate finishes of the step downs on the slab that have to be casted on the same pour? Sample, 8 cm step down between the room and a balcony. Okay, so I hope I understood correctly. We are talking about a step in the part up, steps down on the slab. Okay, so this is like the ceiling. Like see if you see it from, please correct me if I'm wrong, Ricardo, if you are seeing it from below. Over the slab. Okay, over the slab. Yeah, basically what we have done in Jamaica, and not sure if in your country, but what we have done is to have this slight piece of like a cup solution that you attach to the slab with some burros, some steel that you make the shape, and then you put it, you attach it very well there. That's the way that we are doing it. I don't know if that's accurate enough for you, but maybe we can see if you have some issue with that. We can see it and look for a solution. Okay. Thank you for your question. Another one, Catherine Marin. Would have been nice if you said where are you writing from. What are the main activities that should be checked in process reviews before concreting? Okay, it's very important to check the levels, to check that the slabs are well leveled, to check that the dimensions, to check the openings dimensions, to check that they are in the same line, okay? And to check, of course, the alignment of the walls. This is basically what you need to check. Thank you very much, Catherine, for your question. Okay. Any additional questions? Okay, it looks like there are no more questions. So thank you everybody for attending this first webinar. If you need or you want to have additional themes that you want us to discuss, please send us a message. You already have my email. And of course, we will plan another webinar. There is another question from Meredith Gruyon. Where are you from, Meredith? What is the approximate cost of the forms? Good question. Meredith, it depends on the project. It's Dominican Republic. Okay, good, Meredith. Welcome. The cost of the forms depend of the project itself, on how many architectural details you have, if it's complex or not, the area that you have, and we have two lines also. We have our premium, which is the Forza Plus, and in the next weeks we are going to have another form, which is going to be the Forza like Eco. And it's going to be a cheaper option. So the ideal, Meredith, for you is to send us your project drawings, and we will give you an accurate quote, I think, with both solutions. Okay. That's it. Any other question? Thank you, Meredith. Okay, so thank you. I'm going to show you again my email. So you can write direct to me, or please, if you already have the contact of the commercial agent or Diana, you can reach us anytime. Okay. Thank you, guys. Thank you for your time, and hope to see you again.